Hello everyone, today we will solve fair distribution of cookies problem. This problem was asked in LeetCode 297 weekly challenge. The problem statement is you are given an integer array cookies where cookies I denotes the number of cookies in the ith bag. You are also given an integer k that denote the number of children to distribute all the bags of cookies to. All the cookies in the same bag must go to the same child and cannot be split up. The unfairness of the distribution is defined as the maximum total cookies obtained by a single child in the distribution, and we need to return the minimum unfairness of all distribution. Let's discuss the problem. So we take one new example. In first bag we have 30 cookies. In second bag we have 16 cookies, and in third bag we have 15 cookies, and we need to distribute these cookies to two children's. Let's take it as k. So our n is 3 and k is 2. In the problem they have clearly mentioned that all the cookies in the same bag go to same children. That is, we can't split this 30 like 15 goes to the first children and 15 goes to the second children, like that we can't distribute it. So for example, we have children 1 and we have children 2. If we give 30 cookies to our first children and 16 and 15 cookie to the second children, then the total cookies for the first children is having total cookies 30 and the second children having total cookies 31. This is one way to distribute the cookies, and another way is this is children 1 and this is children 2. We can give 30 cookies to first children, then again 16 cookies to the first children, and after that we can give the remaining 15 cookies to our second children. In this case 13 plus 16 46 cookies go to the first children, and 15 cookies go to the second children. So unfairness in this case is the maximum value of cookies distributed among these two children. So the maximum value is 31 in this case, and in the second case the maximum value is 46. So there are so many ways by using which we can distribute these cookies. I have mentioned just two ways. Now at the end, what we have to return? We have to return the minimum unfairness between all the combinations possible. So in this case the answer is 31. So let's discuss the decision tree of distribution, how we can distribute these cookies. Let me change the color of the pen. Okay, so first of all, our two children are having 0 cookies. If we give 30 cookie to our first children, then our first children is having 30 cookie and second children is having 0 cookie. And if we give 30 cookies to our second children, then our second children is having 30 cookie and first children is having 0 cookie. Similarly, all the times we have two choices, whether we can give the bag of cookie to our first children or bag of cookie to the second children. So if we give this 16 cookies, now we are on this 16 cookie bag. So if we give this 16 cookie bag to our first children, then the first children is having 30 plus 16, that is 46 cookie, and 0 cookie to our second children in this case. And similarly, if we give 16 cookie to our second children, then our first children is having 30 cookie and second children is having 0 plus 16 cookie, that is 16 cookie. Similarly, in this case, if we give 16 cookie to our first children, then first children is having 16 cookie and second children is having 30 cookie. And in this case, if we give 16 cookie to our second children, then our first children is having 0 cookie and our second children is having 30 plus 16, that is 46 cookie. Now we come to the 15 cookie. If we give this 15 cookie to our first children, then first children is having 61 cookie and the second children is having 0 cookie. Similarly, if we give this 15 cookie to our second children, then in this case, first children is having 46 cookie and second children is having 0 plus 15, that is 15 cookie. Now in this case, if we give cookies to our first children, then 30 plus 15, 45 cookie to our first children and 16 cookie to our second children. And if we give the 15 cookie to our second children, then first children is having 30 cookie and second children is having 16 plus 15, that is 31 cookie. In this case, our first children is having 16. If we give two cookie to first children, then first children is having 16 plus 15, that is 31 cookie and second children is having 30 cookie. And if we give 15 cookie to our second children, then second children is having 30 plus 15, that is 45 cookies. In this case, if we give 15 cookie to our first children, then first children is having 0 plus 15, that is 15 cookie and the second children is having 46 cookie. And if we give 15 cookie to our second children, then our first children is having 0 cookie and 46 plus 15, that is equal to 61 cookies to our second children. So this is our decision tree. Now in each case, we need to find the maximum cookie distributed among the two children. So if we check for this case, then 61 is the maximum cookie distributed between these two children, and in this case 46 is the maximum cookie distributed. In this case also 40, in this case 45 is the answer. In this case 31, here also 31. In this case 46 is the answer, and in this case maximum is 46, and in this case maximum is 61. So we need to return the minimum unfairness between all the possible values. So the minimum unfairness is 31 in this case. So this is our normal recursion. That is, every time for each bag of cookie we have choices. That is, if we have two children, then we can either give this 30 to first children or to second children. And if we have more than two children, then we have total k choices to make. Let's discuss about time complexity of this solution. So in first level we have to make total two decision, that is 2 to the power 1. In second level we have to make total 4 decision, that is 2 to the power 2. And in third level we have to make total 8 decision, that is 2 to the power 3. If you want to generalize this thing, then the 2 represent number of children, which is k, and the power term represent total number of bags in our list, that is n. So the time complexity of this solution is k to the power n. If we look toward this recursive decision tree, then we can observe that we are making some unnecessary calculations. For example, till here we have find that our unfairness is 31, and if we look toward this case, then unfairness till this level is 46, which is already greater than 31. No matter what calculation we are doing this below level, we are either get unfairness as 46 or some larger value than 46. So we don't need to do these two extra calculations. So to avoid this extra calculation and optimize the solution, we can use backtracking. By using backtracking, we can backtrack from this this level and we avoid doing these two extra calculations because they are having no use. So to use backtracking here, we required some condition by using which we can avoid unnecessary calculation. So the condition is we will keep track of all the maximum amount of candy in each level. For example, in this level the maximum candy is 30, in this level the maximum candy is again 30, here the maximum candy is 46, and here the maximum candy is 46, and compare this maximum candy with our unfairness, and these value represent our unfairness. And if the maximum candy is greater than our unfairness, then we will backtrack from here, that is return from this state. So this is our backtracking condition. So to understand the solution, I have take here small example, but they have mentioned that the length of our arrays go up to 8 and we have maximum 8 students to distribute the candy. So in this case our total number of calculation are 8 to the power 8, and this is very huge number. In this huge decision tree, we can eliminate so many unnecessary calculation and optimize the solution using backtracking. Let's code this problem. They have given us cookies list and k, which represent the number of children. So our n is equal to length of cookie, and to distribute the cookie among k children, we will make an list of children equal to, initially all the children are having 0 cookies, so we initialize the list with 0, and we need to calculate the minimum unfairness. So to calculate minimum unfairness, we will make one variable which represent the minimum unfairness equal to, and we initialize this thing with some maximum value which is float infinite. To solve this problem, I will make one nested function which is cookie distributor, and it will take one parameter as an index, and if our index is greater than or equal to our n, then we will simply return the maximum between all the children. And to distribute cookie among k children, we will make one for loop for I in range k, and to give cookie to our I children, I will assign children I plus equal to cookies of index, that is this indexed cookie bag is given to children number I. After that I will call this cookies distributor for next cookie bag index plus 1, and store the result of current unfairness in the current unfairness variable and compare the minimum unfairness with our current unfairness and our minimum unfairness, and whichever is the minimum we will assign it to our minimum unfairness. After that we take the cookie back from our children I so that we can assign it to another children. So children I, we take the cookie back, that's why we use here minus index, and at the end we simply return our minimum unfairness. Let's call this function cookies distributor 0 and we will return it. So let's check the simple recursion. So here they have given that local variable minimum unfairness referred before assignment. So to assign value to minimum unfairness, we need to use non-local mean unfairness. Now we can assign value to our mean unfairness. So we can see that the simple recursion is working here. But as we have discussed, if we use backtracking, then we can avoid so many unnecessary calculation. So as we have discussed the condition for our backtracking, if maximum of cookie between all the children is greater than our minimum unfairness, then we'll simply return minimum unfairness. Here we can use greater than or equal to. This is our backtracking condition. Let's submit the code now. So our solution got accepted. If you have any doubt regarding the solution, then feel free to ask in comment section. Thanks for watching.